Hello, grade 7. How are you today? I hope you all are safe and well. Today in our chemistry lesson, we will study inquiry lesson about how can science use to explain how can using science to explain predictions. So we will talk about volcanoes. Okay, please open your books on page 64 and grab your highlighter and follow me. Eruption. What's the meaning of volcanoes eruption? Eruption is like breaking or tearing, okay? But it's not like tearing like papers or something, but opening, okay? So, eruption. Pritiwi lives in Java, Indonesia. She writes a diary. In 23rd of October 2010, she wrote, "There were more earthquakes today. They say it's the volcano getting ready to erupt. It's scary." Mount Merapi, Indonesia, erupted in October 2010. 25th of October, she wrote, "My grandparents have been evacuated. Now they are staying with us. The volcano has erupted and there is lava spewing down the southern slopes." In 26th of October, she wrote, "The volcano refuses to rest. Showers of hot rock have been flung high into the sky. There are flames, smoke, and poisonous gases which are hotter than boiling water erupting from the volcano. The gases can move faster than cars. There have been several deaths. It's a tragedy." In 30th of October, she wrote, "The volcano is still active. There's black soot everywhere, and sand is raining down. There was a massive fireball. Thousands of people are traveling to safety, including us." So first it started with the earthquakes, and then the volcano start to be activated, and continued for several days, and it didn't deactivate, or it didn't rest. So she was writing her notes. How can scientists know that the volcano is going to erupt, or how can they warn people about this to evacuate or like go to safe places? Now, first let's take a look what comes out of volcanoes. Here in this photo, in this photo, we have the volcano here. First, down here in the center, we have the magma chamber. It's like the room of the magma, the room of these liquids, which is melted rocks, okay? Then, here, this like a tunnel, okay, called vent, okay? This is called vent. And magma is inside, but when it goes out, like this, out of the volcano, we call it lava, okay? And here, post-lava flows. These lines here, as you can see, these are eruptions from the lava, from the volcano, and they solidified, or they made like tunnels, okay? They made like tunnels. So these are lava flows before, and they formed. Now they formed a mountain, okay? They formed a mountain after they solidified. So what comes out of the volcano? We don't just have lava, we have gases also. So the rock underneath the volcano is very hot. It melts to make magma. So in the beginning, or the origin, in the origin, they are rocks. When they melted, they turned into magma. Magma collects under and inside volcanoes. It comes out of volcano as liquid lava. So in the beginning it will collect as magma under the volcano and inside it, and then goes out as lava. Volcanoes also fling out solid materials like volcanic bombs and ash. You know, it's like a very hot rock, and it can melt something, and it can burn very badly. And gases including sulfur dioxide, carbon dioxide, and water vapor. So these are the gases. The solids materials are volcanic bombs and ash. Gases are sulfur dioxide, carbon dioxide, and water vapor. Now let's see how can scientists explain their predictions. First, we said we have scientists are asking questions. Then they come up with a prediction, but not just a prediction, not just a guess. They have to explain it, okay? They have to explain it scientifically. It's impossible to know exactly when or how a volcano will erupt, but volcanologists work hard to predict what a volcano will do next. They tell people when to evacuate their homes and get out of the way. Volcanologists make observations and measurements. They look for patterns in their data. They use these patterns to help them make predictions. Volcanologists support their predictions with scientific explanations. So here we have scientists that study volcanoes. We call them volcanologists. Okay, these people are working so hard to know any informations or about the volcano's eruption, when it's going to start or something. It's hard to know this, but or how, but they are working hard to know at least is it going to be active or is it not active. So they have to make observations. They have to observe the rocks, the volcanoes, the mountains, okay, and they have to measure the temperatures. They have to measure the smoke. They have to measure many things in the volcano, and also they have to make predictions and to prove it, okay, to know about the eruption, at least when it's going to happen, not exactly, but at least is it going to be active or about to erupt or not. Okay, so we have here three volcanologists. One of them said, my tilt meter measures the steepness of the volcano slope. I predict that when the steepness changes, the volcano is more likely to erupt. This is his prediction. He didn't make his prediction for just guessing or for like thinking. He was observing. He was observing the mountain, okay, the volcano mountain. So he was studying and measuring the tilt of the steepness of the volcano, which is the line. Is it straight? Is it like tilted? Okay, is it steep, like very sharp, or what? Okay, and then his prediction said. He said in his prediction, when the shape of the volcano or the steepness of the volcano changes, that means the volcano is moving, the magma inside is moving and is going to erupt. The other scientist said, I measure the amount of sulfur dioxide gas coming out of the volcano. I predict that if the amount of sulfur dioxide increases, suddenly the volcano will erupt. He studied the carbon dioxide and he measured the carbon dioxide amount that coming out of the volcano. He said this amount, if this amount increased, that means the volcano is likely to erupt. Why is that? He was thinking and predicting that the magma is moving inside too much, that means more reactions happening inside, and it's likely to go to explode. Okay. The other scientist said, I monitor Earth movement near the volcano. I predict that if Earth movements increase, the volcano will soon erupt. So he was measuring the earthquakes or the movement of the volcanoes. That means the magma is moving inside and it's about to get out. So all these were just predictions. Now in their explanations, they have to explain their predictions. Why did they predict these predictions? Okay, they have to be based on scientific information or scientific explanation. So the first one explanation is, changes in the shape of the volcano show that magma is moving inside the volcano. Moving magma means an eruption is likely. The other one who studies the sulfur dioxide, he said, magma contains dissolved sulfur dioxide gas. The gas escapes when magma rises to the surface. Extra sulfur dioxide shows that magma is near the surface. An eruption is likely. The third one said, Earth movements may be caused by magma pushing up against the surface rock. If magma is moving, an eruption is likely. So, as you saw here, three of them made their predictions and explained their predictions based on scientific information. So, how can scientists explain their predictions using science? Okay, so this was all about the inquiry lesson today. Okay, and let's see the last thing. Let's see about benefit of volcanoes. Are they useful? We all know that, or think that volcanoes are bad and dangerous, just dangerous and bad. It's a disaster only. We don't think that it's something useful to humanity or to the earth. So let's see if they are useful or not. So since 1,500 years, volcanoes have killed around 200,000 people. But volcanoes are not all bad. So why they are not bad? Here, because soils formed from volcanic rock are very fertile. That means they are very suitable and for growing plants. Fertile means rich of minerals, okay, that the plant needs. So plants grow well. Water pumped underground gets very hot in volcanic areas. Steam from hot underground rocks generates electricity in many countries, including Indonesia and the Philippines. So, at the end, this volcano or these volcanoes are not just bad, okay? Because the soil or the rock, the soil that formed from these rock after weathering, it can be very fertile, rich of minerals, and plants can grow in very good conditions in it. And also the water pumps underground, and the steam that can generate electricity in many countries. Okay, so it's not bad at all. So don't forget the homeworks. This was all about the predictions. How can they made their prediction? They made their explanation using science to explain their predictions. Don't forget the yellow box, and I hope to see you soon. Safe. Bye bye.